Okay, so here is the long-awaited question 6 then. Like I said in previous videos, question 4, 5, 6 are all linked together through different ways, through sharing common data. In fact, this question 6 is in fact drawing upon the data from question 4. It says, draw a carefully labelled histogram for the train data from question 4. Just show where I got that from originally. Here is question 4. And here's all the train data there, and I've just reproduced this table next door, and here it is. Right then, so if you remember that when we do histograms with unequal bar widths or unequal class widths, as you can see, we've got 0 to 5, 5 to 10, so far so good. Then it suddenly jumps 20 to 30, which is a bar width of 10, 30 to 50, bar width of 20, etc. So when you have unequal bar widths, you've got to be able to present the data in a way that makes sense, and histograms with unequal bar widths can be catered for using this method I'm about to show you. Of course, we've done it in class. This is just the assess now as a bit of revision. It's a really good question. So remember, if we're looking at the first two bits of data there, we've got a bandwidth of honestly, we've got a class width of 5. So if the bar may look a little bit, say, like that, it's only rough, and it's going to start from 0 and go to 5. Clearly, the width of that's going to be 5, isn't it, as a rectangle. Now, we don't know what the height is going to be, but this height will be the frequency density, FD for short. But please, when you do it in a table, literally call it frequency density, because that's what it's called. Not frequency, but frequency density. And the 11, you may remember, is actually taken as the area of each little block or each little bar. So the 11 people are between 0 to 5, or just under 5 it says there, but they're represented by the area of that bar. And if it's an area of a rectangular bar, we can work out the height of this individual bar, and that height will be the frequency density for that particular set of data. So here we go, let's just go back to first principles. It's a rectangle, so frequency density times 5 comes to 11. Therefore the frequency density for that bar will be 11 divided by 5, just as you would find the unknown sign of a rectangle if you knew its area and one of its sides. Take it over and divide it, that came to 2.2. Just do one more, this one here, say. So imagine I've got another little bar, which is actually, it's going to carry on from this end one anyway and go in that direction. But anyway, this is a 5 to 10 bar. In other words, the width is still 5, nothing new there, but it will be a brand new frequency density, because the frequency is 32 and not 11. So 32, if you like, is the area, and is the area. So this area represents 32 people from the age of 5 but just under 10. So 32 of young kids from 9 to 5, 5 to 9 rather. I mean, they don't work 9 to 5 obviously. So that's that. So let's go back to the raw mathematics. So the frequency density for this particular bar, when you multiply by 5, will give you a rectangular area of 32, representing the 32 people there. So the frequency density for that bar is going to be 32 over 5. Pick up my calculator and I that's 6.4. And so I've got two answers. I've got the 2.2 for the first set of data and the 6.4 for the second set of data. And what I've done was to calculate each of these frequency densities. And so if I take this out of the way, I might just put the data there I've just done. So let's just take a look here. Call this frequency density. Not very clear, sorry. Trying. Make the y a little bit like a y. Okay, so what I did was I did 11 divided by 5, 2.2. Let's just change colour then. So that's 2.2. 32 divided by 5, there's my answer, 6.4. I did 28 divided by 5, to read off my answers now, 5.6. 35 divided by 5 is exactly 7, let's call it 7.0. Then I did 45 divided by 10, which is clearly 4.5. Then I did 58 divided by 20, that was 2.9. I did 115 divided by 15, came to 7.7 to one decimal place, and finally I did 76 divided by 25, and I got 3.04 or something. Anyway, 3.0 to one decimal place, and these would be my y-axis, and this will be along my x-axis. So what I'm going to do now, in fact what I have done is prepared the axes anyway. As you can see, the age from 0 to 90, and the frequency density from 0 up to 8, and of course I'll be using 7.7 there. My next job is to actually construct it right now and see what I can do. So quite tricky to do. The height is 2.2 for the first one, and the age range is obviously 0 to 5. So 2.2 up. Here we go. Let's see if I can do it with this facility here. Do it in red so it stands out nicely. So 2.2, 2 squares up, come across, and these are 0 to 5s, aren't they? Just check again. Yeah, 0 to 5s, 2.2 up, and then just drag it down like that. First successful bar. Next one, 6.4 up, and from 5 to 10. Okay, so 6.4 is going to be about here somewhere. 6.5, 6.4, that's quite nice. Drag this down to here, join it, drag that down to the bottom, and there's my 5 to 10 bar. So far they're equal bandwidths, they're equal class widths. Next one, 10 to 15, and height or frequency density 5.6. So 10 to 15, 5.6. 5.6 is here, there, and drop it back down to there. That's lovely. Next one's going to be 15 to 20 with a height of 7. So 15 to 20, height of 7. It's quite easy to do. Join it like that. I've overshot it a little bit there on the cross there, but never mind. That's that one. And then we go from 20 to 30, height of 4.5. 20 to 30, 4.5. Straight across like that. Drag it straight down. It's the first one with a bar width of class width of 10, as opposed to 5 for the others. Next one, we're going to go 30 to 50 with an FD of 2.9. 30 to 50, 2.9, 3 is there, 2.9 is about there. 30 to 50 is quite a fat rectangle, isn't it? So that's right. Next one's going to be 50 to 65 with a height of 7.7. So 50 to 65, 7.7. Let's try and get the 7.7 nailed first. That's 7.5. 7.7 is about there. And we're going to 65, was it? I hope so. Just check again. Yep, 50 to 65. So drag this down. Remember, these bars must be touching because age is a continuous measure. And drag this down as well. So there's your 50 to 50, 50 to 65 grouping. Next one, I've got 65 to 90 and a height of 3. 65 to 90, 3. So drag it across like that, and there's my 90. Stop there, drag it down. That is a lovely histogram. Look at that, beautiful, isn't it? Well, that's got me a grade A straight away, and that's easy. Now, this is the hard bit. Use your histogram. This is part B. Use your histogram to obtain an estimate of the median age. And how does this compare with your answer to 4C? We'll get back to that in a minute. Now, I've got to use a histogram to find the median age. Now, you may recall, all the way back from question 4, that the cumulative frequency is 400. Therefore, I've got 400 people to deal with. Now, if I've got 400 people on the train, that means the 200th person arranged from the youngest to the oldest. Person number 200, or thereabouts, will show the median age. Now, if you look at question 4, I found that the median age was 47 years, but now I've got to find the 200th person here. Now, in which group is the 200th person? Let's go back, we'll find it. Now, 11, 43, 71, 106, 151, so when you add on the 45 onto that 106 and 151, therefore to find the 200th person I have to go into this next group here. So this goes up to person number 209, stopping right there. Therefore, my 200th person, my person with a median age, did I say height earlier? I meant age, will be in the 30 to 50 year bracket. So remember that just for now. I'm in the 30s to 50s, my median age. So my 30s to 50s, so somewhere in here is going to be my median person. So let's just have a quick look at that. Yeah. Now, if I can draw a little bar down here, it doesn't have to be accurate, I'm just doing it in order to do a calculation of sorts. So imagine, say my 200th person is here. Now, in fact, no, I'm going to draw a separate bar in case I ruin this beautiful piece of work. So I'm going to do it freehand here. I have got approximately a bar like this that goes, well, it's too untidy, I'm not having that. It's got to be better than that. I mean, there's rough and there's rough, okay? So imagine I've got a bar like that. This is my 30 to 50 bar. It's got a height of 2.9, just to check again. There it is. This is the relevant grouping in which the 200th person is located. It's got a frequency density of 2.9, and the width I don't know yet. So I know it goes from 30 to 50 maximum. Now, if I slice it down here somewhere, I need to work out exactly where that line is by calculation to find the 200th person. So if I shade this out, this is the area that I want. So let's just take a good look at this. I'm going to pause and think. I'll get back. Okay, I've had a think. Now, watch carefully. I know the 200th person is in here somewhere, but the cumulative frequency, if you go back to question 4, I'll just show you. The cumulative frequency takes us to 209. So therefore, I need to go into here and find the 200th person. Now, how many more people are there from 151 in this grouping to the 200th person in this grouping? Well, I've got 200 people that I'm looking for. The 200th person, rather. Take away these 151. I need to go into that grouping by an extra 49 people. Alright? Have you got that? That's really important that you get that. So I want to go from this group to this group, and I want to find the appropriate width that takes me up to a frequency of 49 people. So let's just zoom forward, and that's why I drew this. This area here has got to represent 49 people. Alright? So I'm going to put a great big red 49 there. 49 people. Remember, up to this limit here we go 151. Up to this limit here we've got 200 and, can't remember, remind me, 209. Therefore the majority will be accounted for going up to the 200th person. Alright, so it's 49. 151 plus 49 takes me to the 200th person, and they're definitely in this group. Now zoom forward again. Sorry I'm buzzing you left and right, but I've got to do this. Right, so I've got to work out the width that gives me an area of 49 to represent those 49 people. So here's the mathematics then. Frequency density times the width has got to come to 49 people. Now this time I know my frequency density. It's 2.9 because this 200th person is located in this bar, and this bar goes as high as FD 2.9. So 2.9 times my mystery width comes to 49 people. Therefore my width is going to be 49 divided by 2.9, and that comes to, I don't know, but I can't wait. So 49 divided by 2.9 equals 16.896. I'm going to call that 16.9, say. So therefore the width from 30 to this barrier here where the 200th person is an extra 16.9 years. Therefore the width from 30 plus 16.9 to take to the 200th person is therefore going to be 46.9 years. Wow, okay, let's make a conclusion. Therefore, in red, blue now. Therefore, 30 plus 16.9 equals 46.9, which is approximately equal to 47 years. And I have just calculated the median age from this histogram. Now back to the question. How does this compare with your answer in 4C part 1? Well, shall we have a look? 4C part 1, the median age 47 years. And there's 4C part 1. What is the median age? Well, that was 47 years. Going forward now, we did the complicated grade A way. We did this not from a cumulative frequency diagram, which is grade B. We had to construct a grade A histogram first with unequal bar widths using this methodology here. I went forward, I plotted all the bars, I chopped this one at an appropriate place. Again, it's only a picture to help me do the maths. I knew that the 200th person will be located in this area somewhere. That's where they're going to be. I knew the height was going to be 2.9, the FD was going to be 2.9. I knew it would be so many years beyond the 30 years of age. I worked out that we had an overhang, so to speak, an overspill of 49 people into this particular grouping here, this particular class, and therefore the area was going to be 49. Working around with these figures, I found that the width to make an area of 49 is must be 16.9 years. So let's just put the word years there, like that. So if it's 16.9 years beyond the 30 years, that comes to roughly 47 years. And I'm really happy with that. It's quite a tricky question, working with these little bars that you have to chop up into little bits. But that's it, and that's the end of the assess. 3 videos for the assess, doing 3 quite different questions, 6 being the most challenging, obviously, because it's grade A rated. And this is Mr. Christou signing off right now. Thank you. Now please study that one, because it's quite tricky.